All right, let me put a couple of these equation problems up on YouTube for you. So as you're working out the problems here, as you're practicing up for the quiz tomorrow, you have a few examples to look at, a few models to look at to make sure you know how to do it. Whenever you're doing these questions where you have to take the equation and write a sentence from it, it's really important that you focus in on getting that nomenclature right. And that might be, for some of you, the best way to approach it, is not to think about these equations, not to think about how I'm going to word this. It's just to start with thinking about the nomenclature and nothing else. We have, in this first equation, 4 different substances. Change to a color you can actually see. We have Na3PO4. We have KOH. We have NaOH. And we have K3PO4. What we want to do is just ignore the equation, ignore what we're doing right now, and just name these compounds. And do nothing more than that. So let's start with this first one, Na3PO4. We look at the first part, Na. That's sodium, and sodium's a metal. Because sodium's a metal, we know this is going to be an ionic compound, so we're going to follow the rules for ionic nomenclature. In the rules for ionic nomenclature, we simply write down the name for our two halves. Na is sodium, and PO4 is on our list of polyatomic ions. That's phosphate. So our positive part is called sodium. Our negative part is called phosphate. After we've named the two parts, we have to go in and figure out if we need a Roman numeral. And that involves looking for sodium, the Na, on our periodic table. If we can find the charge for sodium, we don't need a Roman numeral. If we cannot find the charge for sodium, we do need a Roman numeral. So we look at our periodic table. Sodium is in group 1A. It's a +1 charge. We can look up its charge. We're done. No Roman numeral in this thing. Now move on to the next. Again, we have two parts, the K and the OH. And we start by looking up the K on our periodic table to see if it's a metal or not. Potassium is a metal. It's in group 1A. It's to the left of the metalloids. Since we're starting off with a metal here, we know this is ionic. So again, we use the rules for ionic nomenclature. We name the two parts. K is potassium, and OH is on our list of polyatomic ions. It's hydroxide. Again, once we've named our two parts, we go back and we try to find the oxidation number or the charge for potassium. Like sodium, potassium is in group 1A. Group 1A carries a +1 charge. So we can look up the charge for potassium, no Roman numeral. We have the same two metals on the product side. Sodium's here again, potassium's here again. So again, these are going to be ionic. So we start by naming the two parts. Na is sodium, OH is hydroxide. Again, sodium is a +1. It's a predictable metal, so no Roman numeral. K is potassium. PO4 is phosphate. Once again, potassium is a predictable metal that has a +1 charge, so there is no Roman numeral. When you do it like this, it's no different than the practice we've done before with nomenclature. And if you could do that, you can do this. Once you've established all that, once you've got all these names figured out, now we can come back to the equation, and we can go through and write out a sentence. We start off with the Na3PO4. That's sodium phosphate. The plus sign on the reactant side to be replaced with reacts with. KOH, we now know that's potassium hydroxide. The arrow we can replace with to produce. NaOH we now know is sodium hydroxide. The plus sign on the product side can be replaced with the word and. And the K3PO4 we now know is potassium phosphate. I think if you break it down into two separate parts, if you look at it as a nomenclature assignment first and then a sentence writing assignment second, it might clear up some of your confusion. It might make it easier for you to work with these things. Let's take a look at number 2 on this. Again, let's just write down what we got. We have CF4. We have Br2. We have CBr4. And we have F2. Now we're just going to run through these and we're going to name them. We're going to ignore the equation and we're just going to name them. We have 2 capital letters here. It's a compound. We split it down into the 2 parts, C and F. We looked this one up on the periodic table. The C, carbon. Carbon is to the right of the metalloids. That makes it a non-metal. This is a covalent substance. Now when we have the covalent substances, we have to follow the covalent rules. We have to use the prefixes mono, di, tri, tetra, etc. Rules are, you just make the prefix match the subscript. Don't use mono on the first one. So we look at our first one, there's no subscript on it, that's 1. The prefix would be mono, but we're not allowed to use mono on the first element, so we just write down carbon. On to the second element, subscript 4. The prefix for 4 is tetra. Fluorine becomes fluoride. We only change the ending on the second element, so carbon tetrafluoride is that one's name. Now we move on to Br2. There's only 1 capital letter here. There's nothing to split. There is just one thing. Br is bromine. We do nothing with that 2. When you have 1 capital letter, it's an element. And when you have an element, subscripts don't matter. That 2 is there because bromine is one of the 7 diatomic elements. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. You don't find single atoms of those elements in nature. They always occur as a binary molecule with 2 atoms bonded together. The 2 is there because it has to be there. It doesn't do anything to the name. It doesn't do anything to what you write. If a single capital letter, it's an element. On to the next one, 2 capital letters. So this is a compound. We split it. We look up the first one. That's carbon again. Carbon is to the right of the metalloids. It's a nonmetal. This is another covalent molecule. And that tends to be the case. If it's ionic on one side of the arrow, it's going to be ionic on the other side of the arrow. If it's covalent on one side of the arrow, it's probably covalent on the other side of the arrow. It tends to go hand in hand. So if you identify something as covalent up here, it's probably going to continue being covalent down here. If you identify something as ionic up here, it's going to continue being ionic as you work your way down. There's just a general consistency in the way things work. So again, being covalent, it's mono, di, tri, etc. No subscript on the carbon, so that's 1. But we're not allowed to write mono on the first element, so we just write carbon. We have a 4 again. That's tetra. And the bromine changes to bromide. Carbon tetrabromide. Remember, there's no Roman numerals to worry about when you're dealing with covalent substances. There's no crisscross method when you're writing formulas of covalence. It's just this prefix stuff. Finally, F2. 1 capital letter, nothing to split. It's an element again. And F is fluorine. Again, you ignore the 2 when there's only one capital letter. It's there because it has to be there. It's one of the 7 diatomic elements. It doesn't do anything to what you call it. We only worry about the monos, dis, tris, tetras when we have 2 or more capital letters. Now let's go back and write our sentence, now that we know what everything is. So we start with the CF4. We know that's carbon tetrafluoride. Plus sign on the reactant side is replaced with reacts with. Br2 we now know is bromine. The arrow can be replaced with to produce. CBr4 we now know is carbon tetrabromide. The plus on the product side is replaced with the word and the F2 we now know is fluorine. Again, keep it separate and you might have a better chance of doing them right. Let's move on to the next one. This is the last one I'll do on this. Again, we're just going to write down what we have. We have BAS. We have PTF. And then F's got a 2 on it. We have BA, F2. And we have PTS. Those are our substances we have to name. So let's name them. 2 capital letters, so we split it. We look up the BA on our periodic table to see if it's a metal or non-metal. If it's a metal, we're dealing with an ionic compound. If it's a non-metal, we're dealing with a covalent. BA is barium. It's in group 2A. It's to the left of the metalloid, so it is a metal. So this is ionic. No prefixes this time. We just name the 2 parts. BA is barium. And S is sulfur. That will change to sulfide. We look up barium on the periodic table to see if we can find its charge. Barium is in group 2A, so its charge is +2. It does have a predictable charge. Therefore, it has no Roman numeral. That's it, barium sulfide. Again, 2 capital letters, so we have to split it. We look up the first one on the periodic table. PT is platinum. Platinum is a transition metal. It's in the B groups. Left of the metalloids, it's ionic. So again, in the ionics, we just write down the name of the 2 parts. PT is platinum, F is fluorine, which will change to fluoride because it's an ionic compound. Again, when you have a non-metal, make sure you change the name to IDE. Again, we look up platinum on the periodic table to see if we can find its charge. In the B groups, there are only a few metals there that have predictable charges. We did not put a charge in platinum's box, so we're going to have to calculate a Roman numeral here. This is not a predictable metal. To calculate the Roman numeral, we start on this side. It's 2 times fluorine's charge. The 2 for the subscript here. 2 times fluorine's charge. Fluorine is in group 7A, so the charge is -1, giving us a total negative charge of -2. Now we move over to this side. We make that positive. And we divide by the subscript on the platinum. There is nothing here, so we divide by 1. 2 divided by 1 is 2. That is our Roman numeral. So again, start on the negative side. Take the subscript times the negative charge. That'll give you the total negative charge in your compound. Make it positive, and that's what the absolute value brackets do for us. Make it positive, and divide by the subscript on the metal. Remember, when you have no subscript, like in this case, it's going to be 1. Moving on. Again, 2 capital letters, BA and F. BA is barium again, just like it was up here. F changes to fluoride, just like it did there. Barium is predictable, just like it was up here. No Roman numeral. See, once you got the first part figured out, once you got the first couple figured out, the rest of them become easier as you work your way through. So again, another good reason why you separate these two processes down into the nomenclature first and then worry about writing it later. Once you've got through these first two, these two become a lot easier to do because there's a little bit of repetition that happens here. We had barium up here, we're going to have barium down here. We had fluoride up here, we're going to have fluoride down here. We're just mixing and matching, basically, when we get down to the bottom part. Same thing's going to happen here, and it's going to save us some time. Platinum's a metal, so it's ionic. And we have the platinum and the sulfide, just like we did at the top. Here's a shortcut. Because platinum was a +2 here, it's going to still be a +2 down here. That's not going to change. Very, 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 very seldom have I ever seen anything where the charge changes. You can confirm it. There's no subscript on the sulfur. That means 1 times sulfur's charge. Sulfur's in group 6A, so it's a -2. Make it positive and divide by the subscript on the metal. 2 again. Whatever Roman numeral you calculate up here is probably going to be the exact same Roman numeral down there. It doesn't change. So let's go back and write it out. BAS we now know is barium sulfide. Plus sign over here gets replaced with reacts with. PTF2 we now know is platinum 2 fluoride. The arrow is to produce. BAF2 we now know is barium fluoride. The plus sign over here gets replaced with and PTS we now know is platinum 2 sulfide.